I'm very excited to share a real use case of generative AI model in the real world. If you are looking for a model, a vision model to be specific, which would be useful for visually impaired people who cannot see properly and want to use this technology in order to decipher what exactly an image is saying, then maybe have a look at this model. Because what happens is this model is very small yet very powerful. It can even fit on 5 GB of VRAM and maybe slightly less, but the power is supreme. This new model, which is called as nanoLLaVA, is a powerful multimodal AI model that packs the capabilities of a 1 billion parameter vision language model into just 5 GB of VRAM. This makes it an ideal choice for edge devices, tablet, mobile, or any edge device, bringing cutting edge visual understanding and generation to your devices like never before. Under the hood, nanoLLaVA is based on the powerful QNSE, which is a fine tune of Quen 1.5 billion parameter model and also Google's impressive SIGLIP 400 million model. This model is trained using a data centric approach to ensure optimal performance. All the code, all the model weights are open source under the Apache 2 license. So, really, my heart goes out to this person who has created it. Wonderful, wonderful work and very generous. Now, in this video, I will show you how you can get it installed. The command I will be using it on the Colab, but you can use the exact same commands locally to be run on any Linux system or in Windows in the WSL. You can easily port this to any edge device, Android or whatever you are using. Just you need some innovation there, and that's about it. So let's get started. As I mentioned earlier, I will be using Google Colab for this purpose. And again, very generous of Google because they provide a free GPU. So let's change the runtime to T4 GPU. And now our Google Colab is running on the GPU. First thing we need to do is to grab or install all the prerequisites, which usually include our transformer, our flash attention, accelerate, and that sort of things, which improves the performance of the model. So let's wait for this to install. We might also have to install pillow, but we'll see. Let's wait. The prerequisites are being installed, should be done very soon. These prerequisites are installed, took like 10 minutes to install everything. Okay, now let's install pillow. So we will be using to import the image. I'm not sure if it is already there. Seems like it is already there, which is correct. Okay, so let's import some of the stuff which we have just installed. That should be quick. That is done. Let's suppress some of the warnings so that everything will be sweet and clean. And now set our device to CUDA because we are using GPU. You can even use CPU with it if you feel like it, but I would suggest use GPU even if it's a commodity one. Let's download the model. So we are just specifying our nanoLLaVA here, and it is trusting with remote code true, downloading it from the Hugging Face repository. So let's wait for it to finish. Model is loaded. Let's also get our tokenizer for the nanoLLaVA. That should be quick. That is done. Let's specify our prompt. I'm keeping the prompt simple, so I'm just saying prompt describe this image in detail. And let's also specify our prompt template and also our chatml template, sort of chatml. This is our chatml template. I am start and I am end without the slash n. If that is good, let's also tokenize our prompt, which means convert it into a language which LLM will understand. That is done. And now Let's give it one of the images from, um, maybe I will just upload one image and I will ask about it. So I just click on this folder icon on the left. I am uploading one image from my local system. Let me upload maybe one of my thumbnail of a YouTube video, al.png. Just keep it like this. Click on this folder icon again and let me specify that image in the path in the next cell. I'm just calling it al.png. This is a image file name which I have just uploaded. So it is open. Let's pass it to the model to process it. Let's run it. This will take a bit of a time because model is processing the image. So let's wait for it to finish. And that's done. Now let's get the outputs and print the response. And while this happens, let me also first show you the image and then we will check out the output of this one. So this is one of the YouTube thumbnail for a video which I just created. And let's see what, and I have asked my nanoLLaVA to tell me what exactly is happening in that image. There you go. So it says the image features a man in a blue shirt pointing at a screen. The man appears to be pointing at a screen that seems to be showing a video. The screen is white and appears to be quite large. There are also words written in white letter on the screen. There's a yellow background with black border and a black border around the text. The man is holding a black and white remote control. Totally wrong. I think this pattern here behind my finger, it is taking it as a remote control or maybe this thing. Other than that, I think it has correctly identified some of the colors and what man is doing. So pretty good for a sub 1 billion model. Pretty good. Of course, it needs to be fine tuned more and then you can really make it shine for your edge device. So let's try out with one more image. Now let's ask the model about this image. Let's go back to our collab and then the image name is co.png. Let me run this first command, then let's get model to process this image. And now let's get the output IDs and it is going to print it out. So let me first show you the image again. So it's a bear which is in the wild. Let's go back to Colab. So you see it says the image captures a scene from the wilderness where a brown bear is standing in a stream. Yes, there is a stream. How good is that? The bear has a distinct large head and a brown snout. It has a pair of small black eyes that are wide open. Yep. And its mouth is open as if it's panting. That is amazing. Just imagine that. The bear's ears are also large and brown and its nose is black. The bear's front legs are folded. Not maybe not. And its back legs are slightly lifted, think so. The bear's fur is thick and brown, and there are black spots on its body. The bear is surrounded by greenery, including trees and plants. The water in the stream is clear and brown. There are rocks in the stream, and the water is reflecting the surrounding plants. Let me double check the sort of, yeah. But there is good. There is really good. I mean, amazing stuff. There are a few mistakes, but I think more fine tuning will shine through. Let's try out another one. So I'm just going to ask it about this kangaroos and all this stuff. Let's check this one out. So this image name is for small a. I've already uploaded them as you can see. I'll just close this. Let me first run this and this. Let's wait for it to come back. And again, so in the next image, we have this tree, a sun, or then kangaroos hopping, three kangaroos. So you can see it says that The image is a beautiful portrayal of a sunset scene in the wild. The sky is painted in shades of orange and yellow. Yep, there are several kangaroos. They're running. Amazing stuff. Beautiful. It passes here. Let's try out one final. So this is Australian outback because I'm based in Sydney, Australia. So why not? Let me check if it is able to. So I'm going to ask it, what is the location in this image? Let's say 6.png. Let me go here, and my prompt will be, where is the prompt? What is location in the image? Let's see if it is able to rectify that, because red soil is typically unique to Australia. Let's get the image. Let's get the process image. Let's get the output from the model. The model has detected the desert landscape with large open field trees and a hill in the background, but doesn't know Australia. That is fine. But all in all, really amazing model. Love it. I think there will be a lot of use cases, and I hope that you enjoyed it. If you liked our content, please consider subscribing to the channel. And if you're already subscribed, then please do me a favor and share it among your network, as it helps a lot. Thanks for watching.